But then why are we doing this all? So, you know, where do you see a perfectly straight line like that? Not even that I drew was a perfectly straight line. It just looks like a straight line. And I said before that this might be related to some practical problem, but no practical problem ever matches a line like this, or let alone a circle. A circle is even more difficult to find in real life than a straight line or a hyperbola. So all these are ideas. So these are just, I used the word model before. So a model is something that we think that nature or people or any application that you're thinking about satisfies, but it doesn't. And you can always say that a model is wrong by finding some exception, or just by saying, no, it wasn't really a line. So what is the point? Well, the point is that it helps a lot. It's very effective. Even if numbers don't line up in a perfect line, just by lining up on an approximate line, you can already discover a lot of things about the numbers. For example, you can tell more or less how long it's going to take to reach something just by looking at the first few numbers that line up on the line, even if they're not perfectly lined up. For a circle, if something looks like it's moving in a circle, you can already tell a lot of things. You can tell that they're going to repeat. And if it doesn't repeat exactly, it's going to repeat approximately. So if you pass this point, you're going to pass somewhere close to it next time. And it's going to take more or less the same time to get to it. So this is the idea of orbits. You can start to look at the sky and seeing that, you know, if you wait long enough, you're going to see the same planet going through more or less the same point in the sky after the same time. So this was how astronomers started to look at orbits of planets. But then, of course, as they became better, they discovered that they're not circles. They're gonna be different shapes, and then the shape looks like something that is approximately a circle, but is different, and it's going to satisfy a different equation. It's going to be a bit more complicated than that, and it's going to look a lot more like an ellipse. But it's not going to be a perfect ellipse either, because it's a perfect ellipse only if you had the sun and one planet going around the sun. But as soon as you have the sun, one planet, and then another planet, that's going to mess up with that ellipse. So it's only going to be approximately an ellipse. But why does that matter? Why do we even bother? Well, because that already tells you a lot of things about how the planets behave. And eventually that kind of speculation, well, not just speculation, but the investigation of how these things behave can lead you to very practical applications. For example, you all have GPSs on your phones. Well, GPS would be impossible if we didn't understand how the planets move. If we didn't understand how to position and how to triangulate. And even things that look very fancy, like relativity. You all heard about Einstein. Well, we test the theories of Einstein every day. Every time that you type on Google how to get to somewhere, the way the GPSs work today, they wouldn't work if we didn't understand relativity. It's not even, you know, just the movements of planets, but how the movements of planets alter the way that the space itself is shaped. So what looks like something very speculative, you never know, but it comes back hundreds of years later as something very practical that everybody does on their daily lives. I bet Einstein never thought that it would be essential for finding what your nearest Starbucks store would be.